This lesson will overview a series of examples that use the exponent rules that have been previously explained. In this first example, we have one term, and note that is one term, therefore there can be no distribution here because in the bracket we also have one term. One term times another term is really just one term. So you've actually just got 3 times x squared times -5 times x to the -5. To compute that, we can use the commutative property of multiplication to switch some of the orders around so that 3 is multiplied by -5 and then x squared times x to the -5 because we know how to do those parts. So 3 times -5 is -15. X squared times x to the -5 would be the product rule, so that'd be 2 minus 5, 2 plus -5, which is -3. But we never ever want to leave your final answer as a negative exponent. So we rewrite this as -15 over x cubed. Now, you'll notice that this was actually -15 times 1 over x cubed. But when you perform that, you get here. Another thing to note is that the -15, it does not get put into the denominator because it does not have a negative exponent. So do not confuse your exponent rules with regular rules of multiplication, etc. for whole numbers. Let's take a look at the next example. Here we've got 1 minus -2 to the power of 0. So what does this exponent give us? Well, it's always equal to 1. So we've got 1 minus 1, which is 0. In this next example, you've got a power of -2 applying to the 5 only. So that's -1 over 5 squared using the negative exponent rule, which gives us -1 over 25. Here, the -2 is only applying to the x, so the -5 is on its own, and there's a multiplication there, times 1 over x squared. But when you put that together, you get -5 over x squared. This next one, the -2 exponent is applying to both the -5 and the x completely. So -5 is being taken to the power of -2, and x is being taken to the power of -2. And here we're using this exponent rule where the exponent distributes into each part of the term. So here, now we're taking -5 completely and taking it to the power of -2. So let's first get rid of this negative exponent here, which will be 1 over, and keep it in brackets, -5 squared times 1 over x squared. So that'll be 1 over 25 times 1 over x squared, which is 1 over 25 x squared. This next one, we've got a bunch of negative exponents, but there's this plus here. So if there was a multiplication, you could take this outer exponent and apply it to all the terms inside, all the parts of the terms inside, but here we've got separate terms. So you can treat these separately. We've got 1 over 2 plus 1 over 3, 1 over 4, all to the power of -1. So we need to complete the inside first in this case because of this plus. 1/2 plus 1/3, so that'll actually be 3/6 plus 2/6 over 1/4. So that'll be 5 over 6 over 1 over 4 to the -1. So this is really a division, and remember to divide fractions. You're going to multiply by the reciprocal. And so we've got 5 times 2, which is 10 over 3 to the power of -1. but the negative 1 applies to both the top and the bottom, and so they both switch into 3/10. This next example, the square is applying to everything in this bracket, and the negative third power is applying to everything in this bracket. So we could apply those first. Negative 2 squared, a squared over b cubed squared. There's the times, 4 to the power of negative 3, b to the power of negative 3, a to the power of negative 3. And let's compute that. So negative 2 squared, we can say that's 4. There's an a squared. Now there's a times here, but everything on top is being multiplied together. So let's just write it like that. 4 to the power of negative 3, b to the negative 3. And then b to the 3 to the 2 gives us b to the 6, and a to the negative 3. So I like to rearrange things a little bit so I have all my numbers together, all my a's together, all my b's together. So using the property of commutativity of multiplication, we've got 4 to the 1. You'll notice that's the same thing, times 4 to the negative 3, times a squared times b to the negative 3. And there's no numbers here, so my a term first and my b term. This way, I can combine them based on the same base. So remember, to do any of these rules, you need to have the same base. And so here, we actually do have the same base in our numbers. Sometimes you could just take this and bring it down to the denominator as a 4 to the 3. In this case, though, you'll notice this is 4 to the 1 times 4 to the negative 3. You could use the product rule there. 1 minus 3 is negative 2. And then you've got a to the 2 minus negative 3 and b to the negative 3 minus 6. So that leaves us with 4 to the negative 2, which gives us 4 squared in the denominator, and then a to the 5 and b to the negative 9. So let's just rearrange that, clean that up a bit. We'll have a to the 5 up top, 16 in the bottom, and b to the 9 in the bottom. Next example. Again, you have the option of either applying the exponent of negative 4 to everything first, or doing the inside and then applying the exponent of negative 4. So I'll do it the other way. Last time I put in the exponent into the inside first. This time let's try it the other way. So let's say we just look at the inside first. Now, can we simplify anything here? It's always good to see if you can simplify inside first, actually, because sometimes it'll save you a lot of work. 200 over 8 is actually just 25, so we have negative 25 left up top. And then we've got x to the 3 minus 5, and then we've got y to the minus 5 minus negative 7. And that's all to the power of negative 4. So that's negative 25, x to the power of negative 2, y to the power of negative 5 plus 7, which is 2, all to the power of negative 4. So now if we apply this outside exponent to every term inside, it's perhaps maybe a little easier. So you've got negative 25 to the power of negative 4. Well, in order to do that, you have to go and release the negative exponent. So you have negative 25 still in brackets, but to the power of 4 now. Then you've got x to the power of 8 and y to the power of negative 8. So when we clean that up, 25 to the power of 4, and the negatives will cancel, will be this lovely number. And that'll stay in the denominator. We have x to the 8 in the numerator and y to the 8 in the denominator. So we've got this jumbo question here, and you have a few options. One would be to put the outer exponents inside first, or to simplify inside the brackets first, or you could rearrange things so that the negative exponents become positive. You have many options, so I'd like you to pause and try this on your own, and then come back and see if you end up with the same results, because you should, as long as you're using all of these exponents rules correctly. So, I'm going to actually put my outer exponents inside first, because I don't want to deal with them afterwards, and I want to collect everything together. So, everything is getting taken to the power of -1 here, so that'll leave us with, and it kind of looks like this, but I'm going to, rather than write each one out separately like that, I'm just going to do it in my head. So that'll end up with -6 and then 2. Now this is 2 to the power of -1, a to the power of 2. These are all being taken to the power of 2, so that's 6 squared and 5 squared and a to the -4 and b to the -8. And here everything's taken to the -1, so it's 2 to the -1, b to the 1, a to the -2, 3 to the -1, and b to the 2. So now we've got all these parts. Notice this is multiplied, so everything could actually be seen as all a numerator and all a denominator. I'd like to first arrange all my numbers together, and then my a's and my b's. So I'm going to go ahead and rearrange the top so that I have 6 squared times 2 to the -1. So I've dealt with that and that. Don't forget any terms now. Now we have 8 to the -6, a to the -6, and a to the -4, and a to the -2, and then b squared and b to the 1. And then we've got 2 to the -1, 5 to the 2, 3 to the -1, a to the 2, b to the -8, and b to the 2. Okay, so now this here, we can look at anything that's actually exactly the same can be cancelled. So you notice that 2 to the power of 1 and 2 to the power of -1 and 2 to the power of -1 are the same. B squared and b squared are the same. Let's look at what's left. So we've got 6 squared, which is 36. And then we've got times a to the -6 minus 4 and -2. That gives us -10. That gives us -12. And then we've also got b to the 1. And here we've got 25 times 3 to the -1. So that's going to be times 3 up top. 3 to the 1 up top. Dealt with those. And then a squared and b to the -8. So now we've got 36 times 3, which is 108 up top, over 25. And then we've got a to the -12 minus 2 and b to the 1 minus -8. 108, a to the -14, b to the 9 over 25. And we get rid of our negative exponents, leaving us with 108 b to the 9, 25, a to the 14. Okay. This next one here, we're going to use the product rule, so that's x to the 2a plus 1 plus a minus 1. And here you're just collecting like terms, that's 3a, and 1 minus 1 is gone. So x to the power of 3a. Similarly here, you could have y to the 2m minus m minus 1, which gives us y to the 2m minus m plus 1, which gives us m plus 1. And similarly, you could have a plus 1 times a minus 1 in a bracket, so we need to multiply it all out. When you distribute, you get a squared minus a plus a minus 1. Middle terms cancel, you get t to the power of a squared minus 1.